are given the expanded form of the equation of a circle, noticing that the coefficients of x squared and y squared are both equal. This is characteristic of the equation of a circle. We are asked to write this equation in the standard form, x minus h squared plus y minus k squared equals r squared, where the center of the circle has the coordinates h and k. I'm going to assume that you already know how to complete the square, and so the first step is to group the x squared and the x term, leaving space for completing the square, and the y squared and the y term, leaving the 14 on the right-hand side. Now, whatever we do to the left side, we're also going to have to do to the right side of the equation to keep it as a true statement. The first thing we're going to do is add half of the coefficient of x squared to both sides. That's negative 1 squared, which is 1. We add that both to the left and the right. We've now completed the square in x. We do the same thing for completing the square in y, where the coefficient of y is also a negative 2, so we're adding negative 1 squared, which again is 1. We've added the 1 to each of these groupings so that we'll be able to factor each of the groupings and write them as perfect squares. So we now see that the center is 1, 1, since both h and k are 1, and that the radius squared is 16. Using the square root principle gives us that the radius is plus or minus the square root of 16 plus or minus 4, but of course we're only going to use the positive 4 here because a radius is always positive. So we have center at 1, 1 and radius 4.